All right, this is going to be a pretty short video with just two more properties from our text on finding determinants. The first is if you have an n by n matrix, then the determinant of the transpose of that matrix should be the same as the determinant of the original. And also theorem 6, if A and B are n by n matrices, then the determinant of the multiplication of those matrices should be the determinant of A times the determinant of B. In the example in the book, it says to only verify theorem 6, but I actually want to verify theorem 5 as well. So let's look at what A transpose would be. It says take the first row and make it the first column. So notice when we do that, especially in a 2 by 2, your determinant, right, 12 minus 3, is the same thing as it is here, 12 minus 3. Okay, so switching those things, your multiplication pieces are all going to end up being the same. Okay. All right, so I know that the determinant of A is 9. Let's find the determinant of B. So 8 minus 3 is 5. And so that means the determinant of A times the determinant of B in this would be 9 times 5, which is 45. All right, let's go ahead and find A times B and then take the determinant. So AB is 24 plus 1, 25. 18 plus 2, 20. 12 plus 2, 14. 9 plus 4, 13. Oops, so sorry. All right, if I take the determinant of AB then, I get 25 times 13 minus 20 times 14. That gives me 325 minus 280, which is 45. Now you can't just have one example and be like, oh, theorem is proved, but it's just telling you like use these two to show that this theorem does actually work, which is pretty cool. It is important to note that the addition does not work. So the determinant of A plus B is not equal to the determinant of A plus the determinant of B. This is just because of how multiplication versus addition works really at the base of it all. But you could show that A plus B, when you take that determinant, it does not give you 14. And it would kind of show why that's the case.